Hi, my name is Hamizan bin Shafrizal. I'm from 3DEN. My matrix number is D0217101170 and my supervisor's name is Dr. Hu Chin Fun. So for today, I will explain and demonstrate about my project, which is Smart Sleep Training Lamp for Children. Let's get started. Introduction. As children grow up, they went from sleep together with their parent until they separate rooms from their parents. As they newly sleep alone in the room, these children might have scare and fear of the environment. Referring to Lathrop University School of Psychological Science, children tend to be afraid of unfamiliar things that they do not understand or can't control. Their active imagination and their inability to always distinguish between reality and fantasy means they may believe that monsters under the bed or in the wardrobe waiting to spring once the lights goes out. Based on the problem, the observation of these children was done to overcome their fear by inventing the smart sleep training lamp. This project basically to make an automatic light system that will turn on when a child suddenly wakes up in the midnight. By that, children will feel safe when the room is not in the dark, and it can reduce power consumption by not turning on light all night. Problem statement. Children may feel fear under dark environment in their sleep training. So, a smart sleep training lamp is designed to turn light automatically when they wake up in the midnight. At the end, this may assist the children to overcome their fear. Objective. First, to set the heart rate pulse sensor on the user. Second, to design the automatic light system by the microcontroller. Literature review. The history and development of heart rate monitoring. In the 1980s, the first wireless heart rate monitoring was developed, consisting of a transmitter and a receiver. The transmitter could be attached to the chest using either disposable electrode or an elastic electrode belt. The receiver was a watch-like monitor worn on the wrist. The development of the relatively small wireless monitor resulted in an increased utilization of heart rate monitoring by athletes. As a consequence, the objective measure of heart rate replaced the more subjective perceived exertion as an indicator of exercise intensity. In the 20 years after the development of the first monitor, heart rate monitoring has been developed with larger memory capacity. This allows for storage of heart rate data from exercise session. Heart rate data can be downloaded into a computer, which makes the analysis of training, race, or exercise tests possible. More recently, heart rate monitoring has been equipped with a calorie counting feature and estimation of maximum oxygen uptake, VO2 max. Another relatively recent development in heart rate monitoring is the measurement of heart rate variability that may have various applications. This feature and their reliability and validity will be discussed in the following section. Heart rate variability. Even when heart rate is relatively stable, the time between two beats R to R can differ substantially. The variation in time between beats is being defined as heart rate variability. Currently, variation in interbeat interval are used as an index of autonomic responsiveness. High heart rate variability is associated with high VO2 max value, while it has been found that low heart rate variability is associated with increased mortality, the incidence of new cardiac event, and risk of sudden cardiac death in asymptomatic patients. Methodology. First, I received project title from supervisor, and then I made a research about the project component and equipment. After that, I will make a component testing and writing program coding. After I finish doing that, I will do a design circuit connection and installation component on breadboard. Then I will make a circuit interface with written program coding and troubleshoot circuit and modify program if needed. After that, I will design a prototype project and do a project testing. If my project testing got some problem, I will do the circuit interface with written program coding again and do as the following step. Flowchart and block diagram. My project is a bit simple, so let's start with the flowchart first. If I turn on the system, it will scan the heart rate pulse and make a reading. Microcontroller will make a decision. If the BPM is below 60, it will turn off light, and if the BPM above 60, it will turn on light. For the block diagram, you will start with the heart rate sensor, go to the Arduino Pro Mini, then will go to relay circuit, and last to the light system. Project development. For my project, I use hardware and software. For hardware, I use Arduino Pro Mini, heart rate sensor, relay, resistor, LED, transistor and diode. And for software, I use two software which is Proteus and Arduino IDE. Circuit using Proteus. This is my schematic diagram. As you can see, I use relay, diode, transistor, resistor and LED for my relay circuit. Circuit on board. The first picture is when BPM is below 60 and bottom picture is when the BPM above 60. Next, we will see how my project running. Discussion. From the observation that have been made, the heart rate sensor can detect heart rate functionally and can be attached to the user. The light system also can be automatic turn on and turn off based on the BPM user by microcontroller. The objective of the project had been achieved successfully. Conclusion. The Smart Sleep Training Lane for Children is the result of observation that I have been made. I want differences in the implementation of the project presented by its method and application are useful and beneficial to everyone. Practical work skill during learning in the last semester has been used for the creation of this project. That's all for me. If you have any question, please let me know in the section comment below. Thank you for watching. Bye.